in another slide who Professor Han prepared. And buoyancy, which is upward acting force to balance object's weights. So if weight and buoyancy is equal, then we call this is equilibrium. And the amount of buoyancy is same as a weight of displaced water. So as you can see in this picture, if this volume solid object is in here, then the buoyancy is same as the mass of this volume water at this volume of water. And here's the equation. And hydrostatic spring. So if I push this object to downward, then buoyancy gets bigger. So it goes up and keep it down and up like spring. So it goes to equilibrium state. And this is pressure in static fluid. And if equilibrium, then this part of force plus mass is same as this part of force. So P delta X delta Y means pressure multiplies by this dimension. And also this part is pressure, and delta X delta Y also this surface. And pressure in a static fluid is in same depth, then same pressure is existing. So pressure increases with only depth or density, as I mentioned in previous slide. So, but direction is like, or this part perpendicular to the surface. So as you can see in this picture, water comes this part, this arrow direction, which is perpendicular to this surface. And this water goes more faster than upper water because it has more depth. So it has higher pressure. And this is buoyancy of submerged body. If fully submerged and it is in equilibrium, then which means this volume submerged and in its equilibrium. In this object, the mass is this object's volume multiplied by rho, and the buoyancy is this volume of water multiplied by rho of water. So it means this object has same rho with water and partially submerged, then this mass means this volume multiplied by object's rho, and the buoyancy of this is this volume multiplied by water rho. So it has lower rho than water, so it's floating. So when you see the iceberg, then we usually call that's only 10% of the iceberg, because rho of ice is 0.91 times rho of water. So only 9% is floated and 91% is submerged. And here's a submarine, also goes fully submerged and floating, and fully submerged and floating. So inside submarine there is air and water, and you can add water in this tank or drain this water and push air in this tank. And if you change the water and air, you can make it higher low or lower low, so you can be in neutral, or you can go down, or you can go up. This video shows how the submarine works well, so you can check.
They can reach depths of about 800 feet thanks to a system of internal and external ballast tanks.
We have 5 external ballast tanks that are normally filled with air when I'm riding on the surface. When it is time for us to dive, we'll open vents on those ballast tanks. There's grates on the bottom of the ship that allow water to come in, displace the air, making the ship just slightly negatively buoyant. We then proceed down to the depth that we want to go to. And we use internal ballast tanks to make the ship neutrally buoyant, that then we can progress on our way in whatever depth we choose.
The crew on board the Virginia class have an abundance of cutting-edge controls at their fingertips, one of which is replacing the most iconic feature in submarine history. The periscope has been a key component on the submarine for over 100 years, but engineers on the Virginia class are taking a bold step toward the future by replacing the periscope with a state-of-the-art photonic mast.
The photonic system is a mast with a sophisticated camera system that allows what would normally be displayed just in a periscope to be displayed on widescreen monitors throughout the ship.
I used to have an optical periscope that came down, which drove the construction of the submarine and the orientation of all of the rooms on the submarine.
Bulky periscopes force most submarine control rooms to be located on a cramped upper deck. On the Virginia class, the compact imaging equipment is housed in a part of the submarine known as the sail. This allows the sub's control room to be built on the wider second deck.
My control room that I'm standing in right now houses all of the important decision makers. It really brings the crew together to operate as a team, as a unit.
And still here is the summary of fluid dynamics. Is there any question? And I can go on. This is stability of a system and 3 states of equilibrium: stable and neutral and unstable. So if I push these 3 balls to left like this, then as you can see, stable will come back and neutral will keep here, and unstable falling down, right? So stable and neutral and unstable is like this picture. And in case of ship, stability is very important because ship must be sufficiently stable, or if not, then it overturns like this picture. It's a very severe accident. So when we say a ship is stable, Then in still water, float upright and return to its initial upright position if given a slight temporary deflection to either side by some external forces like disturbance. Here's the question. High buoyancy means object is more floatable. In this slide, right? I think high buoyancy is like just a force to keep this precise. So same volume, which means same volume has submerged, then same buoyancy is existed. So low is more like floatable component because okay, thank you. Is there any question? Back in this slide. Stable, and it have to return to initial upright position. As I said in this slide, ship goes here, like this position, then ship must come back to initial position, which means stable. And unstable ships then keep moving in this tilted state, or even in unstable ships, it gets overturned. Then what makes unstable? Then it's high center of gravity. Then we say usually unstable. So what makes higher center of gravity is overload or poor fixation, like this car. So if we get high center of gravity, we need careful turning, because sudden change occurs, then overturn. So if we turn, then our ship or in this truck get tilted. So center of gravity is not in this surface, then it gets overturned, like this figure. So here's what I prepared. And is there any question?
Thank you.
Thank you.
Very much. If there is no more questions, then we can move on to the discussion session. Led by Usung-min, please.
hear my voice?
Yes.
Yeah.
Okay. Yes. Let's start the discussion class. Today's discussion topic is about ship's hydrostatics. Ship's hydrostatics are highly related to the stability of the ship, which is the important factor in determining the ship's safety and stability. Next slide shows some appendages to improve ship's
Sungmin,
stability.
can you
Yes.
use the slideshow?
Oh.
The letters font size smaller or bigger screen.
Okay, okay, yes.
Or it is PDF, then you can use a Control L to make a. Oh, this is PowerPoint. Then you can use slideshow.
Yeah.
Yes, thank you.
Okay. Yes. There are some appendages to improve ship's stability. First of all, vehicle structure. Vehicle is the additional structure in the form of long plate on the bottom of the ship. This is representative for reducing ship's roll motion. Yes, by increasing viscosity of viscous resistance. And second, anti-rolling tank. As you see the right picture, there is a U-shaped large water tanks inside the ship. It can reduce ship's roll motion by generating a phase difference between water in the tank and inclined ship. Yes, and the water roll period should be antiphase with the ship's roll period to avoid the ship's roll resonance. And third, stabilizing fin. Stabilizing fin on the both sides of the ships reduce the ship's roll motion due to the lift and down force generated by stabilizing fin.
How are those two different? The fin and the cube?
Yes. Stabilizing fin can rotate this plate. By rotating this plate, it can generating the lift or down force. So by this force, the ship's rolling motion is reduced. Okay. The first discussion topic is like this. The stability of the ship is an important factor for the safety of the ship. As you see the previous slide, there are several appendages to reduce ship's roll motion. Besides several devices mentioned previous slide, please suggest the method of appendages to improve ship's stability. Feel free to tell us your opinion.
Okay, can we start?
Yes.
Okay, I have two suggestions in addition to the three appendages you mentioned. The first one maybe outriggers. It's like it's like a projecting structure. That's the equivalent of, say, for example, wheeled vehicles, legs on wheeled vehicles that are folded out when it needs stabilizing. That's that equivalent. That kind of equivalent to boats. It will reduce rolling and also increase stability. Another appendage may be an active system that's you may be using gyroscope. It may need energy to that, but we can also use gyroscopes to stabilize the ship. Gyroscope it consists spinning wheel and precision equipment. So the angular momentum, as the angular momentum of the flywheel increases, the resisting force of the gyroscope to external torque increases. That means it's going to be more stable. So we may use these two additional appendages.
I wanted to add a point as well. Um, so the appendage that I'm trying to talk about, it was actually told to me by Sangmin during our our own group presentation meeting. So it is something like having kind of like airbags on both sides of the ship. So when when the ship is about to roll this way, the airbag over here can inflate and it can help the ship to stabilize it. That's, I think, an efficient way and a cost-effective way to prevent overturning.
I don't know about the new technologies, but by your some examples, I was just thought like in anti-rolling tank, keep center of gravity. Low center of gravity means more stable, so we can add more high viscosity fluids inside the tank. Then maybe it gets more stable.
I think that we may add some propeller or water jet to control the ships, like spaceship's attitude control thruster, to make an active control for the rowing and roaming.
Okay, thank you for informative ideas. Oh, yes. Yes, there have been various maritime accidents. Among the kind of accidents, I summarized some cases of overturn due to the cause of ship instability. First of all, Serpent. It is this accident is occurred in April 2019. The reason for rollover was a combination of human errors and incorrect correct response, and some other technical problems. And second, the soil ferry. This is caused by an uneven weight distribution. And so the main factor for sinking is overloading. Most of the weight of was concentrated near the bow. And finally, this is container ship's accident, more compact container ship. This is the rollover case of cases for one of the most rollover accident of container ship. It is caused by hull girder crack. The bottom shell plates experienced fast deformation, so it is fractured. So the second discussion topic is as follows. There has been numerous overturning accidents in the history of the ships. So to prevent a rollover accident, please suggest some ideas in following steps. First, ship's design stage, and second, inspection stage before launching the ship. And finally, regular maintenance. By usually operating company for regular maintenance. So please suggest some ideas for each step.
Is it okay if I talk about a potential solution which is not exactly related to the 3 points here?
Sorry, could you repeat again? Yeah.
Is it okay if I give an idea which is not related to the 3 points given in the
Yeah,
slide?
sure. Please feel free to tell us. Yeah.
So while doing the first homework for this class, I read a few papers about current research trend, and one of the papers that I referenced in that homework, in there they were talking about how most of the ship accidents that are happening due to human error, as also mentioned by someone in the first 2 cases here.